Hello and welcome back to the basic organic chemistry course. Today we will continue with the amines functional group and we will divide it into 4 lectures. The first one we will talk about structures and properties of amines. First of all, what is an amine? Amine is an organic derivative of ammonia, which is the NH3 molecule with one or more alkyl or aryl groups bonded to the nitrogen atom. If you look at the first molecule, dopamine, which is a neurotransmitter, it has the ammonia that is bonded to one alkyl group. Or epinephrine, which is the adrenal hormone, it has the ammonia bonded to two alkyl groups. Lastly, for L3-1, which is one of the amino acids, it has two nitrogen atoms. The first one is the ammonia that is bonded with one alkyl group, and the second one has the nitrogen atom in the part of the aromatic system, the indole system, and we call this the heteroaromatic amine. And because of their high degree of biological activities, as you can see in this example, many amines are used as drugs and medicines. And also they can be found in nature as an alkaloid, which is the important group of biologically active amines, mostly synthesized by plants to protect them from being eaten by insects or other animals. For example, as you might already heard, cocaine has the amine in the structure as well, and it is bonded to 3 alkyl groups, 1, 2, and 3. Okay. Or nicotine has two nitrogen atoms. The first one bonded to 3 alkyl groups, and the second one is a part of aromatic system, pyridine. So this is another heteroaromatic amine. And last one, as everyone should have heard before, is morphine in opium poppies, and this is an amine that bonded to 3 alkyl groups. And most of the alkaloids are toxic and cause death if taken in large quantities, but because of their biological activities, many of them are used as a platform for development of new drugs in future. You can classify amines by the number of groups connected to the nitrogen. If you have one group connected to the nitrogen, for example, cyclohexylamine, it has only one carbon here connected to the nitrogen, or third-butylamine, it has only one carbon connected to the nitrogen. We call them primary amine. And for secondary amine, there are 2 groups connected to the nitrogen. For example, this molecule has one alkyl and one aryl group connected to the amine, and this molecule has 2 alkyl groups connected to it. So they are called secondary amine. And lastly, if you have 3 alkyl or aryl groups, we call them tertiary amines. For example, this molecule has 2 alkyl groups and 1 aryl group. Or this molecule has 3 alkyl groups connected to a nitrogen, so we call them tertiary amines. Actually, nitrogen can form up to 4 bonds. However, itself needs to become positively charged to comply with the octet rule. So the compound that has 4 bonds at the nitrogen with positive charge, we call them quaternary ammonium salts. For example, this molecule, you have nitrogen bonded to 4 alkyl groups and itself bearing positive charge. So this is one of the quaternary ammonium salts structure. For the nomenclature of amine, we will use the suffix of amine at the end. For example, this molecule without the NH2 groups has 4 carbons, right? So it should start with bute, and if there is no double bonds or triple bond, it should stop with ane, so it's butane. But if we want to specify that there is an amino group at the second carbon. So the amino group is connected at the second carbon, then we cut out the E, okay, and then we put in the number 2 and follow with the suffix amine. So it becomes butan 2-amine like this. Okay. For the next molecule, we have again a butane, but at this time you have the amino group connected at the first position, and also you have the methyl group connected at the third position. So we will start with the butane, right? And then we cut the E out and then put number 1 to specify that the amine is connected at the first position, and then we put in the prefix to specify that there is a methyl group at the third position, so it's 3-methyl butane 1-amine like this. Okay. For the next molecule, it is also the butan 2-amine as well, because you have the butane that has amine connected to the second position. But in this case, you have a substituent methyl connected to the nitrogen. So what you do is you put the prefix and specify that it connects to the nitrogen by using the capital nitrogen letter with italic format. So N-methyl butane 2-amine like this. Okay. Last molecule, you can see that there is a really long main chain here with 1, 2, 3, 4, 5, 6 carbons. So we start with hexane, and then we cut the E out to put to specify that the nitrogen is connected at the third position. 1, 2, 3, 4. Okay, so the nitrogen connects at the third position, so it becomes hexane 3-amine. Okay, and then for the substituent, we have 4 methyl groups, 1, 2, 3, 4, connected to the second carbon, the fourth carbon, and twice at the nitrogen. So what we need to use is to put the prefix, specify that it connects to the second carbon, fourth carbon, and both of the nitrogens. Okay, and then we use tetramethyl to specify that there are 4 methyl groups. So it becomes 2,4-NN tetramethyl hexane 3-amines. For aromatic and heterocyclic amines, there are a large number of them, and it is quite difficult to use the naming system for these. So people usually use their historical names or the common names. And the one that I would like you to focus is the aniline, which is just a benzene connected to the nitrogen, and also pyridine, which is the nitrogen inside the aromatic system. The rest of the molecule system are quite important, but not as much as these two. So maybe you can learn in future if you want. And the derivatives of aniline, you just use aniline as your the main chain, and then you just add, for example, this ethyl group, you can add them as a prefix in front. Or for this compound, you have 2 ethyl group connected at the nitrogen, so it becomes N-diethyl aniline like this. Okay. For the structure of amines, both amines and ammonia have slightly distorted tetrahedral shape. So if you look at the structure of ammonia, as you can see here, it has kind of like the trigonal pyramidal shape with the lone pair pointing at the sp3 hybridized orbital here. And if you replace one hydrogen with an R group, it will remain similar to this shape. So kind of like the trigonal pyramidal shape. or you can replace more hydrogens with the R groups to have primary, secondary, or tertiary amines. But one thing that doesn't change is that this lone pair here, and also the electronegativity of the nitrogen, as you can see, it has higher En than carbons or hydrogen, so it will pull electron towards itself, and you have partial negative charge at the nitrogen, as you can see in this red region here, which is the localization of the lone pair with the partial negative charge. And therefore, from this property, you may imagine that ammonia or amines should be able to act as a nucleophile by giving this lone pair, donating this lone pair to electrophiles. And this will reflect in its reactivities later on in this lecture. Okay. For the physical properties of amines, we are going to focus on two types of properties: the boiling point and the water solubility of the amines. And these properties are governed by the intermolecular forces between each molecule. And we can divide intermolecular forces into three types, right? London interaction, which depends on the molecular weight. The higher the molecular weight, the higher the London force. The second is the dipole-dipole interaction, and the third is the hydrogen bonding. As we mentioned in the last slide, that nitrogen has high electronegativity than carbons or hydrogen. Therefore, it will pull electron towards itself, and this creates the permanent dipole. And we should be able to know that the amines is the polar molecule. When the molecule is polar or has permanent dipole moment, that means it always have the dipole-dipole interaction between each molecule. And moreover, if your amines have is the primary or secondary amine, you are going to have the NH bond, right? And this NH bond will create the partially positive charge of the hydrogen and the partially negative charge of the nitrogen. And these two charges will so the lone pair of the nitrogen will attract the partially positive charge of the hydrogen, forming the hydrogen bonding between these two. So for primary and secondary amine, you will have the hydrogen bonding between itself. Okay, and for the water solubility, apart from primary and secondary amine, so of course, primary and secondary amines can also form hydrogen bonding with water as well, right? So for example, if you have a secondary amine, you have a lone pair of the nitrogen. This one can form the hydrogen bonding with the hydrogen of water, and this hydrogen can form hydrogen bonding with the oxygen of water. That means it should have high water solubility. But don't forget, even though the tertiary amines cannot form hydrogen with itself, but the lone pair of the amine can form hydrogen bonding with water. So although the boiling point of tertiary amine might not be high because there is no hydrogen bonding between itself, but it can form hydrogen bonding with water, so it still might be able to be soluble in water. So just to sum up, the primary and secondary amines have the NH bond, right? So with this NH bond, this means that they can form the hydrogen bonding with itself, and they should have higher boiling point than the tertiary amine. However, and also they can form hydrogen bonding with water as well, so they should have high water solubility as well compared to, for example, alkane. But for tertiary amine, because there is no hydrogen bonded to the nitrogen, so that this molecule cannot form hydrogen bonding with itself. Therefore, it will have lower boiling point, right? But still, it will still can form hydrogen bonding with water because it still have lone pair on the nitrogen. Therefore, it should still have a high water solubility, same as the primary or secondary amine. If you look at the real example, the triethylamine here is the tertiary amine, right? It doesn't have NH bond. Therefore, if you look at the boiling point, it has boiling point of only 3. And if you compare with the ether with the similar molecular weight, so the London interaction should be quite similar. The ether doesn't have hydrogen bonding neither, so it has low boiling point in the same range with the tertiary amine. However, if you compare with the secondary amine, now you have the NH bond here. Therefore, even though it has the same molecular weight as the rest, but it has much higher boiling point than tertiary amines or ether, because apart from dipole-dipole interaction, it also can form hydrogen bonding with itself. Okay, same as primary amine, it also has the hydrogen bonding with itself. Therefore, it has similar boiling point with the secondary amines, which is higher than that of ether and that of tertiary amine. However, if you compare with the alcohol, this is has much higher boiling point than secondary or primary amine. That is because alcohol has oxygen, which forms stronger hydrogen bonding. Because if you compare oxygen and nitrogen, the En of oxygen is much higher than the nitrogen. Therefore, it will create more charge separation, and the charge interaction is higher for alcohol. Therefore, alcohol has higher boiling point than the amines with the similar molecular weight. Okay. Another important properties of amines is that they have their characteristic odor, which is quite stinky. And normally for example triethylamine, they don't have very pleasant smell. It have smell like a rotten fish. But if you have more than one amine, for example, this molecule butane 1,4-diamine or pentane 1,5-diamine, they have two functional groups, amine functional groups, and this has even more stinky smell. So even the name putrescine or cadaverine reflects its smell like stinky or corpse. So for the example, if you need to rank the boiling point of these 4 molecules, you can see that this molecule is the primary amine, right? And this molecule is tertiary amine. This molecule doesn't have any functional group, so this is just an alkane. And last molecule is secondary amine. And if you before you compare other activities, other interaction, you need to compare the London interaction first by comparing the molecular weight of these molecules. So if you look at these molecules, they all have 1, 2, 3, 4, 5, 6 carbon and 1 nitrogen, right? This one also has 6 carbon and 1 nitrogen. This one has 7 carbon, so should have similar molecular weight than the others. And last one has 2, 4, 6, 8 carbons and 1 nitrogen. Therefore, for London, this one, and this one should have similar London forces, but this one should have highest London interaction. And for the dipole-dipole interaction, the amines, any types of amines has trigonopyramidal shape, and therefore it should have it should be polar, right? When there are polar molecules, they should have dipole-dipole interaction. But for alkane, because carbon and hydrogen has similar electronegativities, so there is no dipole-dipole interaction for the alkane. Lastly, for hydrogen bonding, definitely alkane doesn't have hydrogen bonding, right? Same as tertiary amine, because it doesn't have NH, so they cannot form hydrogen bonding to each other. For primary amine, it has NH bond, so it can form hydrogen bonding to each other. Same as secondary amine, right? So if you compare all of these, therefore this molecule should have highest boiling point because it has both dipole-dipole interaction and hydrogen bonding, as well as the highest London interaction. And this molecule should have the second highest boiling point because it has both dipole-dipole interaction and hydrogen bonding, but it has slightly less dipole-dipole London interaction to the fourth molecule. And the tertiary amine should be the third highest boiling point, and the alkane, because it doesn't have any dipole-dipole or hydrogen bonding, it will have the lowest boiling point in this series. The other example, if you need to rank the water solubility of these molecules, first of all, you need to see that this is a tertiary amine, right? And this is the secondary amine. This one is also a primary amine. And this one is the aromatic ring without any functional groups. So for water solubility, you need to see if they can form hydrogen bonding with water. And for tertiary amine, you have a lone pair here that can form hydrogen bonding with water. For secondary amine, you have a lone pair that can form hydrogen bonding with water as well as the NH. For primary amine, same, you have the lone pair as well as two hydrogens that can form hydrogen bonding with water. And for aromatic system, there is no groups that can form hydrogen bonding with water. So if we mark this group as the hydrophilic region, so this is called hydrophilic. So these nitrogens are hydrophilic, and the alkyl parts are hydrophobic because they cannot form hydrogen bonding and they don't have high dipole-dipole interactions. So from here, you can see that the secondary amine here can form lots of hydrogen bonding to water, and it has lowest amount of hydrophobic region. Therefore, this one should be the most soluble in water. And this tertiary amine has hydrophilic region and second most. It has also hydrophobic region, but not as much as this molecule. This one has an aromatic system which is quite large. So the hydrophobic region is quite large here, but it still have hydrophilic region. And this one definitely doesn't have any hydrophilic region at all. So this one should have the lowest solubility compared to the rest of the molecule.